Welcome to the last section in our unit. Yay! All right, so let's take a look. We're going to look at multiple angle formulas. And these formulas, I'll quickly derive the double angle ones because they come right from our sum formulas. So we're looking at double angle, like sine of 2u, cosine of 2u, tan of 2u, where the angle is doubled. And they come from here, like I said, sine of u plus v, remember, is sine u cosine v plus sine v cosine u. But what if the angles were the same, sine of u plus u? Just make all the v's u's. So sine u cosine u plus sine u cosine u. Well, these are the same exact thing, so you can actually combine u plus u is 2u, and sine u cosine u plus sine u cosine u is 2 sine u cosine u. Yay! There's your first double angle formula right there. We do the same trick with cosine. Cosine of u plus v is this. Let's make all the v's a u. This time we're going to get cosine times cosine. Cosine u is cosine squared u. And sine u times sine u is sine squared u. So this one's actually going to have a couple different forms. It's actually going to have 3 forms to it. So this is one form. I'm going to summarize all this on the next page. This is one form. If we use the Pythagorean identity to rewrite cosine squared as 1 minus sine squared, then we can combine the sine squareds and we get this form. Or, starting back up here, if I rewrite sine squared as 1 minus cosine squared, now cosine u minus a negative cosine u, or cosine squared u minus a negative cosine squared u is 2 cosine squared u minus 1. And then again, we do the same exact thing with tangent. Tan of u plus v is this. Make all the v's a u, you get this. So if you combine like terms, tan u plus tan u is 2 tan u. And on the bottom, tan u times tan u is tan squared u. And I'll be honest, a lot of times from year to year, I may not remember these formulas, but I always remember these, and that's exactly how I get them, is just very quickly deriving them. Especially it's this tangent one. We don't use it very often. So this one I don't always remember, but I remember this one and I can get there really quickly. So maybe that'll help you with memorizing. So as far as the formulas that are going to be used in this section, here's the double angle formulas that we just derived. The half angle formulas take a little longer, so I'm not going to do that. But here they are, half angle formulas, because we are taking half the angle. Haha. Now, one little note with sine and cosine. Notice it says plus or minus the square root, plus or minus the square root. The sign that you're going to use is going to depend on what quadrant u over 2 lies in. So if u over 2 is in a quadrant where sine is positive, you're going to use the positive square root. If u over 2 is negative, then if u over 2 lies in a quadrant where sine is negative, then you're going to use the negative square root. And likewise for cosine. So that's the only little caveat with these that you'll have to remember. All right, let's just do some examples now. All right, here's example 1. We're going to look at 5 examples altogether, if you're keeping track. All right, so we got this. Sine of theta. That's just straightforward. That's opposite of our hypotenuse, but oh no, we don't have the opposite side. We have to do the Pythagorean theorem. We'll get 4. Sine is 4/5. All right. Now we know that sine of 2 theta, if you look at that formula that I gave you, is 2 sine theta cosine theta. I'm actually going to move this below. And now, because we were given theta, not 2 theta, so we have to change it so that we are back in terms of theta. But now we can do this. We know the sine of theta is 4/5, and the cosine of theta is 3/5. And then just multiply. 2 times 4 times 3 is 24. 5 times 5 is 25. 24/25. And then finally the sine of theta over 2. We're just dealing with a right triangle. So we know, since theta is an acute angle, theta over 2 has to also be acute. Actually, I should have had a right angle there. Otherwise, we really can't do this problem. So we know that the square root's positive, though. And the formula is 1 minus cosine theta over 2. And again, cosine of theta is 3/5. It's all in a square root. 1 minus 3/5 is 2/5. Half of 2/5 is 1/5. But we have to rationalize our denominator. Oops. Well, here, let me make it more clear, because this is the square root of 1 over the square root of 5. So it's root 5 over 5 when you simplify. There you go. One thing to notice is when we double the angle, notice we don't just double the answer for sine. We have to use these formulas. When we halve the angle, we don't just half the angle for sine, or the answer for sine. But just use your formulas, trust in the formula. All right, so that was example 1. Let's look at the next one. Okay, well, let's see here. We have a little bit of a dilemma in this equation. First of all, not only do we have 2 different trig functions, we have a cosine and a sine, but we also have 2 different angles, 2x and x. And we can't just factor to separate them. Now the first goal is, let's get these to the same angle. So I'm going to use a double angle formula. Now remember, cosine of 2x, that's the one with 3 different versions. And if you think about this formula, the other term has a sine. I'm going to scroll back up here for a second. So cosine 2u, it has these 3 versions. Let's use this version because it also will put us all in terms of sine. And that's going to be useful. So I'm going to use this one for the cosine of 2u. So we have cosine 2x plus sine x equals 0. But we know that cosine 2x is 1 minus 2 sine squared x. Oh, look at that. It looks like it's going to be 1 to factor. It's a quadratic. Now my squared term currently is negative. I find it so much easier to factor when my squared term is positive. So I'm going to move everything to the right-hand side. And then I can factor much easier. Because, again, if you practice, you get to the point where you can do these in your head and you don't need to set up that Australian method. So I just factored it without the Australian method. I'll just go through it though real quick. A times C, negative 2, B, negative 1, whoops. What multiplies to negative 2 but adds up to negative 1 is negative 2 and positive 1. Divide them both by A and simplify when you can. So sine x minus 1 is one factor. 2 sine x plus 1 is the other factor. Now we can use the zero product property. 2 sine x plus 1 equals 0. Sine of x is negative 1/2. We're in quadrant 3 and 4 because that's where sine is negative. Reference angle is pi over 6. So we're going to have, I'm going to set this up in quadrant 3. We're going to be 7 pi over 6. And in quadrant 4, it's 11 pi over 6. And then when sine of x minus 1 equals 0, that means sine of x is equal to 1. And if we just think in one rotation of the circle first, it will equal 1 at pi over 2. But since it said to find all solutions, I have to add 2 pi n to each of these answers. And we're done. Yay! So there's this problem. All right, example 3 coming up. All right, so let's look at this. We were given cosine of theta, but we have to find sine 2 theta, cosine 2 theta, and tan 2 theta. It looks like double angles. They did tell us that cosine theta, like what it equals and which quadrant it's in. It's going to be in quadrant 2. Let's draw a picture. So cosine of theta was negative 2 over 3. Pythagorean theorem makes that a root 5. And now it's just a matter of using the formulas. We know that sine of 2 theta is 2 sine theta cosine theta. And then we can use our picture to see that the sine of theta is root 5 over 3. Cosine theta is negative 2 over 3. So it's going to be negative 4 root 5 over 9. Wait a minute. I'm confused here. We're in quadrant 2 where sine is positive. Why are we getting a negative answer for sine? Think about that one. Did you figure it out yet? The reason why we're getting a negative answer is because we're taking the sine of 2 theta, not theta. Yes, theta is in quadrant 2, but I'm going to go over here to the side. We were given that pi over 2 is less than theta is less than pi. If we double everything, that means that pi is less than 2 theta is less than 2 pi. 2 theta is between pi and 2 pi. That's anywhere in quadrants 3 and 4 where sine is negative. So that's why we got a negative answer here. It's not a surprise. It's not wrong. It was actually expected. There's something to think about. All right, now cosine 2 theta, we actually have, remember that's the one with 3 different versions. It doesn't matter which one of those 3 versions you use, you will get the same answer. I'm just going to use this one. But again, any one of the 3 versions will give you the same answer. And cosine theta was negative 2/3, but we're squaring it. So that's going to be 2 times 4/9 minus 1, which is going to be 8/9. And 8/9 minus 1 is negative 1/9. And again, it's okay that we're getting a negative answer. If theta is between pi over 2 and pi, 2 theta has to be between pi and 2 pi. And now we've actually narrowed it down. Again, pi to 2 pi is anywhere in quadrants 3 or 4. But if cosine of 2 theta is going to give us a negative answer, we got to be here in quadrant 3. If you were to actually draw this triangle with these exact lengths and find this measure of theta and then doubled it, you're going to find that that angle measures in quadrant 3. Hey, look at that. All right, let's look at tangent. I'm going to put tangent over here so I can try to fit everything on one. Move this up. So tan 2 theta. So if we look at that one, that actually had a couple of different versions as well. I'm going to go up here for a second. Oh, actually, sorry, I take it back. I was thinking of this one. This one only has one, so never mind. I'm just going to use this version because that's our only one. Haha. I can find our problem. There it is. So it is 2 tan theta over 1 minus tan squared theta. And we can see from the picture, tangent theta is negative root 5 over 2. And 1 minus tangent theta, which is also negative 5 over 2, but this is squared. All right, let's see what happens now when we simplify this. The numerator, we're just going to get negative root 5. And in the denominator, we're going to get 1 minus, and if we square negative, it's positive. Square root 5, you get 5 over 4. We're getting negative root 5 over negative 1/4, which is negative root 5 times negative 4 over 1, which is positive 4 root 5, which again isn't unexpected We knew 2 theta was going to be in quadrants 3 or 4. Because cosine of 2 theta ended up being negative, that meant we were in quadrant 3, where tangent is positive. Oh my god, it's like the pieces fit together. So, there you go, just using the formulas. Let's try another problem. Okay, now this time we're going to practice the half-angle formulas. And honestly, half-angle formulas are my least favorite, but they're a necessary evil. So, it says use a half-angle formulas to find the exact value of. Well, let's go ahead and try to do this. Now, it's tempting to, because it says we're going to use the half angles, it's tempting to just take half of this, but you're actually going to want to double this. And here's why. If u is equal to 7 pi over 12, then u over 2, what would that be? That'd be 7 pi over 24. This is not getting us anywhere. These are not our friendly angles. That's not going to help us. That's not what it means. That's not how we're going to use our half-angle formulas. Instead, assume that u over 2 is 7 pi over 12. That means u is 7 pi over 6. That's an angle we can deal with. So here's the way it's going to look. The sine of 7 pi over 12 is equal to the sine of 7 pi over 6 over 2. Let me get rid of this because I'm going to use that space. So take a look. Sine, we've now rewritten the problem as the sine of u over 2. And then when you go to the formula, the sine of u over 2 is, well, actually this is going to be ones that I do want to remind us because these are the caveat ones. Remember, we've also got that plus or minus. So we have to think about what quadrant u over 2 is in to know if it's a plus or minus. But we now know that u is 7 pi over 6. So we've rewritten the angle so that it's u over 2, so we have the value of u. Let's see. So many problems. Okay, here we go. 7 pi over 12. Think about which quadrant that's in. It's going to be in quadrant 2, where sine is positive. So we know we're going to use the positive square root, and the formula says 1 minus cosine u over 2. So now let's figure out this. 7 pi over 6 is in quadrant 3, where cosine is negative. It's got a reference angle of pi over 6, and cosine of pi over 6 is root 3 over 2. And it's all over 2. So now we got to simplify this mess. Well, the numerator is just going to be 1 plus root 3 over 2, but it's all over 2. Inside the square root, I'm going to multiply by 2 over 2 so that I can simplify this complex fraction. So the numerator is 2 plus root 3, and the denominator is 4. But now I take the square root of the top, which I can't really do anything with, but the square root of the bottom is 2, and there's my final answer. And yes, when you use the half-angle formulas, you will often get these nested radicals, and that is totally fine. Totally normal. Now that we got that one, you're going to see the other ones are very similar now. Cosine of 7 pi over 12 is the same thing as cosine of 7 pi over 6 over 2. Now remember, 7 pi over 12 is in quadrant 2, where cosine is negative. So I'm going to use the negative square root. And this formula is 1 plus cosine u. over 2. But now you're going to see the work is all very similar, because we're still dealing with cosine of 7 pi over 6. So in that respect, once you do the work for one of the problems, it kind of falls into place for the other one. So cosine of 7 pi over 6 is still negative root 3 over 2. And we're still going to multiply top and bottom by root 2 to simplify the complex fraction. So we're going to get 2 minus root 3 on the top, 4 on the bottom. And by the way, notice I'm very careful to make my square root so it's clear that the denominator is inside there. But notice how I put the fraction bar long enough to make it clear that the square root only goes to the numerator here. Make sure your work is clear, because if it is not, I will not give full credit. Some of you guys really need to work on how you're showing your work, because it is not clear. Can't give you credit when it's not clear. If it's not mathematical, I can't give you credit. So there's those guys. Now, before we do tangent, I want to go back and look at the formula there to point something out. So, this is the one I was thinking of earlier. We got two different versions. And quite honestly, I always like to use this version. And the reason for that is there's only a single term in the denominator instead of two terms. Because as you're seeing, we're often dealing with square roots in our answers. If we happen to get a square root in the denominator, I don't want to have to multiply by the conjugate because I got two terms in the denominator. I just want to multiply by a radical to rationalize, make it much easier. So I almost exclusively use this version because of that. It's up to you. You'll get the same answer again no matter which one you use. I just prefer this one. So let's go back there. And we are dealing with the tangent of 7 pi over 12, which is the same thing as the tangent of 7 pi over 6 over 2. So the formula said 1 minus cosine u over sine of u. And let's see here, cosine of 7 pi over 6, we've already worked that out, is negative root 3 over 2. 7 pi over 6 was in quadrant 3, where sine is negative. Reference angle is pi over 6. The sine of pi over 6 is negative 1/2. Ooh, I don't even have to rationalize my denominator. Yay! So I'm going to have 1 plus root 3 over 2 on the top, over 1 over 2 on the bottom. If I multiply by 2 over 2, I will get 2 plus root 3 over 1, which I don't need. There's my answer. Yay! Okay, one more example and then we're done. We have to use an equation here. Couldn't let you go without doing an equation with half angles. All right, so we're dealing with tangent where we still have the two options. I don't know. Let's go ahead, see what happens when we, I would say like pick one. Somebody pick one, but I can't hear what you say. That's so sad to me. Let's just use the one that I say I like to use. Tangent of x over 2 is the same thing as 1 minus cosine x over sine x. Well, looks like I could multiply both sides by sine x. It'll cancel out with the sine x in the bottom of the fraction. And then it's going to have to distribute over there to the sine squared. Can you think of what we do now? If you were thinking Pythagorean identities, you were right. Sine squared is 1 minus cosine squared. Yay! So the 1 minus 1 are going to cancel. I'll have negative cosine x plus cosine squared x. We can factor out a cosine. And then set each factor equal to 0. And we are staying in the interval 0 to 2 pi, so we only have to worry about one rotation. Cosine is 0 at pi over 2 and 3 pi over 2. Over here, we get cosine x is 1. And in the interval, there's only one place where cosine is 1. So putting all of our answers together, we have 0, pi over 2, and 3 pi over 2. There you go. That gives you some ideas of how to use the double and half angle formulas. So that is it. Have fun. I'll see you in class.